Hi, welcome to part 2 of the A5 side glass theoretical revolve surface. I have changed this curve here now to degree 3, deleted those construction curves we had there, we don't need them anymore, and this is the curve that we're interested in. And you should now measure its deviation from the 3D curve. So let's take deviation, and you see we've got deviation of 0.24 there, and here 0.3. Okay, we're ready to make our revolve. So take the revolve tool and we're going to set it to, let's sweep for the whole 360 degrees. That's not what I normally do, but it makes it simpler. And we want it split into segments. We don't want it in one piece, so we can have 4 segments, degree 3, single span. Go for local axis on the direction of the x-axis. So we're ready to go with that. There's our revolve, which will be our theoretical side glass. The first thing to do is check its radius. We've got a radius of 694. Take extend with merge on. And then what we have to ask ourselves is the 3D curve containing the deviations from the model, or is it our side glass? And really, to be honest with you, I would keep the side glass because we made that with pure geometry. And as you can see, it's got absolutely wonderful highlights. But you know, assuming that you had to direct model it, let's do that now. So that's covered. We're going to go for NUV as our mode of movement, and our sensitivity we go to 250. Type that in, and it's no good with that shader. We need this one, and we're ready to start. So I'm going to just pull out, probably at that point there, just a touch. Let's use the cross-section editor now, and first of all we'll look at our X sections, and they don't look too bad. These ones look very good. It's a bit flat here, so NUV, I'm going to take those 2 points in, just to out, just to get a bit more, match up that curvature there, and it looks pretty consistent. Okay, yeah, that's all in order, isn't it? Come down here and get curve to surface. You see the deviation here is 1 millimeter. Down there in the corner, so I'm not too worried about right at the moment, it's 2 millimeters. It's less than 1 mil there, which is okay. Okay, so it's just at this point where we need to possibly to tweak the surface, but once again we're not sure whether it's probably the 3D curve that's out, but you know, I'll show you how to correct it because it's useful to know how to use all these tools. So I'm using mouse sensitivity of 250, and I'm going to pull this out to reduce the Okay, so we're less than 1mm, which is the accuracy we'd work to if we were working from a mesh, so I'm happy with that. We'll check with our cross-section editor again, and now we see we have a really very symmetrical surface, which is very nice. We don't need that anymore. And this is the shade that I recommend for evaluating glass, as it's the most realistic for glass surface. Maybe a touch more. And you can see that it's a very, very nice surface, and it needs to be, because a lot of the model is built from that surface. So there we are, the finished theoretical side glass surface. And just to remind you, the reason that I refer to it as a theoretical surface is because it's not actually ever going to be glass. This is the sheet metal from which we build the shoulder blend and the cant rail, also the A pillar and C pillar, and the actual side glass itself is a derivative of this surface. It's an offset from this surface. So I hope that you found this useful tutorial, and thank you for taking your time to watch it.